Secondary 1. Science, free revision notes. Particulate nature of matter. Content covered. Brownian motion and smoke particles. Nature of solid, liquid, and gas. Volume and density of matter. Behavior of particles upon heating and cooling. Diffusion of particles. Brownian motion. Random movement of small particles in a liquid or gas. Due to collisions between particles, i.e. smoke particles and air particles. Real-life application, transmission of airborne diseases. Experiments showing smoke particles are moving in random directions. Models are used to explain complex, difficult to understand, ideas. Particulate nature of matter. Starting with solid, the particles vibrate about their fixed position, are very closely packed in an orderly manner, and has a strong attraction force. Next, liquid particles slide past one another, are closely packed in a disorderly manner, and has moderately strong force of attraction. Lastly, gas particles move randomly at various speeds, are far apart from each other in a disorderly manner, and has a weak force of attraction. Volume and density. Density equals amount of matter / volume. Using particle theory, solids will have more particles packed together per unit volume compared to liquids and gases. Behavior of particles upon heating and cooling. What happens to the particles in the matter? When heated, they gain energy and move faster. Heat helps them overcome the forces of attraction and move further from one another. Distance between particles increases, volume increases, but number of particles does not. Hence, matter expands. What happens to the particles in the matter? When cooled, they lose energy and move slower. Particles are unable to overcome the forces of attraction and move close to one another. Distance between particles decreases, volume decreases, but number of particles does not. Hence, matter contracts. During melting, particles gain energy and vibrate vigorously about its fixed position. When they have enough energy to overcome the forces of attraction, they slide over one another. During freezing, particles lose energy and vibrate less vigorously about their position. When they lose enough energy to allow the forces of attraction to pull them into a fixed position. During condensation, particles lose energy and vibrate less vigorously about their position. When they lose enough energy to allow the forces of attraction to pull them closer and slide over one another. During boiling, particles gain energy and vibrate more vigorously about their position. When they gain enough energy to overcome the forces of attraction and move far away from one another. Diffusion of particles. Particles are in constant and random motion. Net movement of particles from a region of higher concentration to a region of lower concentration until both regions are of equal concentration. Concentration is the number of particles per unit volume. No external energy is required for diffusion. Examples in real life: food coloring, perfume, medical imaging, carbonated drink.